Good day to you all. You're welcome to today's class. I remain your pro guide, Aisha Bandi. The video is sponsored by Crush Connect, which is an application for undergraduate, College of Education, university, and even polytechnic students. Kindly go to the Play Store and search for Crush Connect for you to get started for exciting and educative video. So today in chemistry, there's a topic we'll be discussing, which is called rate of reaction. This rate of reaction is a subtopic under the topic called chemical equilibrium, but we will be discussing the rate of reaction today, which has the abbreviation of ROR, that is rate of reaction. So we shall be looking at the definition of rate of reaction, the factors that affect the rate of reaction. Also, we answer some few questions and we discuss some important terminologies we need to know under this rate of reaction. And also we move on to the calculation aspect where we'll treat the measurement of rate of reaction. We all know we have different types of reactions. We have displacement, substitution, and complex reactions. So basically, some reactants are slow, some are very slow, while some are fast. Example of reactions that are slow is seen in aging of metals. Reactions that are very slow, reaction of medication in the human body, and reactions that are fast are seen in situations like reaction of acid with sodium in water. That's a very fast reaction. So these are some examples of reactions that we have. So now this now takes us to the definition of rate of reaction. So rate of reaction is a measure of how fast a reaction will occur. It's just as simple and as straightforward as that, okay? Let's answer this question on the board, which says, when does reaction happen? So reaction happens when atoms, elements, molecules collide with the proper orientation and sufficient energy. But we have to note that not all collision actually results to a reaction. Okay, so moving on, and let's go to what we have next, which is called the activation energy. So activation energy is defined as the minimum, that is the smallest amount of energy needed to break the bonds between atoms of reactants. So that's what activation energy is all about. Example of activation energy in real life is seen in when you want to go to the other side of a hill. Let's explain this using a diagram. Let's say you want to go to the other side of a hill. You know, for you to get to that top of the hill is where where you need the activation energy. So as you're going to the top of a hill, you need an activation energy. But when coming down, you can just easily, slide down. Mm? So let's explain this in the form of a diagram. Okay, let's say this is a hill, right? You are at this point, and you want to go to the other side of this hill, this point here. Let's call here point A, this is point B. So you're at point A and you want to go to the other side of this hill as the other is at point B. So where you need the activation energy is at the top of this hill here. So this is where we need the activation energy, right? So this side here is what we call the reactant side in a chemical reaction, which is A plus B. Then when you come to the other side of the hill, here is where we have the product, okay? So the product here is going to be A times B, which is AB. So this is thus the real life illustration of activation energy. So moving on, there are factors that affect rate of reaction. We have concentration, temperature, pressure, and also catalyst. So these are some of the few factors that affect any type of rate of reaction, okay? So for a reaction to occur, there are some conditions that have to be met. And some of the conditions include number one, collision. So there must be collision between reactants. Another condition, proper orientation. The third one is concentration. And the last one, sufficient energy. So these are some of the few conditions that must be met for any rate of reaction to occur. So this takes us to what we have next, which is the measurement of rate of reaction. This is where we start the calculation aspect of the topic. Rate of reaction can be measured by measuring the amount of reactant to be consumed or the amount of product formed over a given period of time. Okay, so that's how rate of reaction is measured. So the mathematical representation for rate of reaction, or the formula for rate of reaction, is given as change in concentration over time. So we have the rate of reaction is given as the change in concentration all over time. So this is the formula for the rate of reaction. We have a mathematical problem under the rate of reaction for better understanding.